When you look at a picture of Earth from space, it looks calm and peaceful, but it's actually a buzzing, active, incredibly complex place. It's not just a dead rock, it's a dynamic system. Think of it like a giant, intricate machine. It has moving parts, the land, the water, the air, and every living thing. And they are all constantly interacting, all connected. We're going to figure out how that machine works. So here's our main goal. We want to understand what makes Earth so active. Why do we have volcanoes and earthquakes? Why do we have rivers that carve giant canyons? Are those two things, a volcano and a river, related? The short answer is yes. They are all part of one big story. We're going to build a model to show how Earth's internal processes, like volcanism, and its surface processes, like erosion, are connected. We'll find out what powers them and how they've shaped every feature of our planet. You hear the word system all the time, but in science it has a specific meaning. A system is just any group of parts that work together to do something. Your phone is a system. A car engine is a system. Your school is a system. A system has inputs, like gas for the car, and outputs, like motion. Earth is the same, just way, way bigger. Its inputs are energy, and its outputs are, well, everything we see. Mountains, clouds, life, oceans, all are outputs of the Earth system. To make sense of a system as big as Earth, we have to simplify it. Scientists model Earth by dividing it into four main components, or spheres. Think of them as four big families that all live in the same house. You have the Geosphere, which is all the solid rocky stuff. The Hydrosphere, which is all the water. The Atmosphere, which is all the air. And the Biosphere, which is all the life, including us. The key idea? None of these spheres is truly separate. They are constantly overlapping and interacting. Let's start with the ground beneath our feet, the geosphere. This is the part of the planet that feels solid. It includes all the rocks you can see, like mountains and canyons, and all the stuff you can't, like the gooey mantle and the super hot iron core. So, when you're thinking about volcanoes, earthquakes, the seafloor, or even just the sand on a beach, you're thinking about the geosphere. It's the land part of our planet. Next up is the hydrosphere. This is all the water on Earth in every form. Most of it, about 97%, is the salt water in our oceans. The other 3% is the fresh water we rely on, found in rivers, lakes, and trapped underground as groundwater. But don't forget the frozen water. The giant ice caps in Antarctica and Greenland and all the glaciers are also part of the hydrosphere. Scientists sometimes give this frozen part its own name, the cryosphere. The atmosphere is the thin, fragile blanket of air that surrounds the planet. We often take it for granted, but we couldn't last 2 minutes without it. It's mostly nitrogen and oxygen gas. This thin layer does two critical jobs. It acts like a shield, protecting the biosphere from the sun's most harmful radiation, and it acts like a greenhouse, trapping just enough heat to keep the planet warm. It's also where all of our weather, clouds, wind, and storms happens. Finally, there's the biosphere. Bio means life. This sphere includes every single living thing, from the smallest bacteria in the soil to the largest blue whale in the ocean, from the tallest redwood tree to, well, you. Humans are a huge and very powerful part of the biosphere. We are the only species that can knowingly change all of an entire planet's other spheres, like a giant feedback loop. Okay, we have our four spheres, but what makes them do anything? Why isn't Earth just a static, boring ball of rock, water, air, and life? Because it has engines, 2 of them. Think of it like a hybrid car. It has 2 sources of power. The first is an external engine, the sun. The second is an internal engine, the planet's own heat, deep inside its core. These two engines provide all the energy that drives every process on Earth. The first engine is the one we see every day, the sun. Its energy, called radiation, is the gas for almost everything that happens on Earth's surface. It's the sun's heat that evaporates water from the ocean to create clouds and rain. It's the sun's uneven heating of the planet that creates high and low pressure zones, which we feel as wind. And of course, the sun provides the light that plants use for photosynthesis, which is the foundation of the entire food web. The second engine is hidden deep beneath our feet, Earth's internal heat. When Earth first formed, it was a molten ball of rock, and it's still incredibly hot in the center. A lot of that heat is also still being generated by the radioactive decay of elements like uranium in the core and mantle. This heat has to go somewhere, so it flows outward. It causes the semi-solid mantle to churn very slowly, like a thick soup simmering on a stove. This slow, powerful motion is the gas for all of Earth's internal processes. So what does that simmering soup in the mantle do? It moves the geosphere. The solid crust we live on isn't one solid piece. It's broken into giant puzzle pieces called tectonic plates. These huge plates are floating on top of that churning mantle. As the mantle moves, it drags the plates with it. This is plate tectonics. In some places, they crash together. In others, they pull apart. This movement is the ground floor of geology. The internal engine, plate tectonics, is Earth's construction crew. It builds land. When two plates, both carrying continents, crash into each other, they have nowhere to go but up. The rock buckles and folds, creating massive mountain ranges. This is how the Himalayas were born. In other places, magma from the mantle can push through the crust to form a volcano. When that lava cools, it creates brand new rock, building new land and new islands, like Hawaii. So, the internal engine builds up the geosphere. But there's another force at work. While the internal engine builds land up, the external engine, the sun, works to tear it down. The sun's energy powers wind, rain, and ice. This is called weathering and erosion. Rain and ice seep into cracks in those mountains and break them apart. Rivers, powered by gravity and the water cycle, act like conveyor belts, carrying all those broken pieces of rock, called sediment, downhill. Eventually, they get deposited in new places, like a river delta at the edge of the sea. Here's the most important concept. These spheres and engines are constantly talking to each other. Let's imagine a big volcanic eruption. That's the geosphere in action. It blasts tons of ash and gas into the atmosphere. That ash cloud can be so thick that it blocks sunlight, cooling the whole planet. This affects the biosphere as plants struggle to grow. And when that ash settles, it can fall into rivers and lakes, changing the chemistry of the hydrosphere. See? One event, 4 spheres all affected. Let's take a more common example. A rainstorm. It all starts with the sun's energy. That energy beats down on the hydrosphere, the ocean, causing evaporation. That water vapor rises into the atmosphere to form clouds. The atmosphere, wind, then blows those clouds over the geosphere, the land. The hydrosphere, rain, falls, watering the biosphere, plants and animals. That same rain then runs downhill, carving into the geosphere, erosion, and flowing back to the ocean. Every single sphere is involved. These interactions can get complex. Sometimes they create feedback loops. A feedback loop is just what it sounds like, a cycle where the result of an action feeds back and changes the action itself. A negative feedback loop is like a thermostat. When your house gets too hot, the thermostat stops the heat. It keeps things stable. A positive feedback loop is like a microphone squeal. A little sound goes into the mic, gets amplified, comes out the speaker and goes back into the mic, getting louder and louder. It accelerates a change. The most famous example of a positive feedback loop on Earth is the ice albedo effect. Albedo is just a word for how reflective a surface is. White ice is very reflective. It bounces sunlight and heat back into space. Dark ocean water is not. It absorbs heat. So here's the loop. The planet warms up a little, atmosphere. This causes some of that bright white ice to melt, hydrosphere. This exposes the darker land or ocean underneath. This dark surface absorbs more sunlight, which makes the planet warmer, which melts even more ice. The process feeds on itself, accelerating the change. When you put all these interactions and engines together over millions of years, you get Earth's big recycling programs. The major cycles. The rock cycle is the perfect example. The internal engine, heat, melts rock into magma, which cools into new igneous rock. Then, the external engine, the sun, powers erosion, breaking that rock down into sediment. That sediment gets buried and pressed together, forming sedimentary rock. If that rock gets pushed deep enough, heat and pressure cook it into metamorphic rock. It's a constant recycling of the geosphere. The carbon and water cycles work the same way, moving materials through all four spheres. So let's sum up our model. Earth is not a collection of separate things. It's a single dynamic system made of four interacting parts: the geosphere, hydrosphere, atmosphere, and biosphere. This entire system is driven by two engines: the sun's external energy, which shapes the surface, and Earth's internal heat, which builds the land. These forces are in a constant push and pull, creating the cycles, feedback loops, and beautiful, complex planet we call home.